So now that we got to know why we need the machine exception delegation register and machine interrupt delegation register, now let's explore the machine exception delegation register. So this register is one of the control status register in RISC-V architecture. As the name of this register implies, this register is only accessible in the machine mode because this register starts with the M letter. And about this slide, this diagram will show you default control flow when the exception occurs in the user mode. For better understanding, so let's go through each step one by one. As the first step, the memory override occurs in the user mode. As you know, in the user mode, user application usually runs. But by default, in this case, the controllers move to the exception handler, trap handler in the machine mode. The RISC-V halt move to the trap handler in machine mode in this case. This is a default operation. What I mean is that if you do not modify any the bit field inside machine exception delegation registers, RISC-V core will move to the trap handler in the machine mode. That is the default operation. Now let's take a look at another the workflow when the exception occurs in the supervisor mode. So please remember that this is the default setting. What I mean is that if you do not configure any the bit field inside these registers, control flow will be on this kind of some slide. As you can see, as the first step, the memory override occurs in the supervisor mode. In the supervisor mode, Linux kernel runs. This is the standard, the convention in our industry. But if you do not configure any the bit field inside this register, the RISC-V cores move to the address of the trap handler. In this case, the privilege mode switched from supervisor mode to the machine mode. So this is the workflow when the exception occurs in the user mode or supervisor mode. So now that you get to know about why we need this register as background knowledge, so let's explore layout of this register. Important point is bit position of this register is identical to the value of exception code. This table outlined exception code in the RISC-V architecture. After the RISC-V generate exception, that this value will be updated in the either machine cost register or supervisor cost register. But the value of exception code is corresponding to bit position. For example, exception due to illegal instruction. As for this specific exception code is 2. Please look at this. But bit position for some illegal instruction in the machine exception delegation register is 2. As for environment call from user mode, its score value for exception code is 8. But as for machine exception delegation register, 8th bit position is to configure the environment call from the user mode. The important point is the bit position of the machine exception delegation register is corresponding to the value of the exception code. The important thing you need to understand is if you turn on the each bit flag, then specific type of exception will be delegated to the supervisor mode. For example, if you turn on the second bit position inside machine exception delegation registers, all of the exception due to illegal instruction will be taken to the supervisor mode instead of machine mode. As for this specific exception, that is environment call from the user mode. If you turn on the bit flag, this kinds of exception is taken to the supervisor mode instead of the machine mode. So every time, many of the system software engineer customize the bootloader, many of them usually they set each bit field in the bootloader to configure the workflow of the control flow of the exception. Because each bit flag inside the machine exception delegation register will affect the control flow of the exception. So once you configure each bit flag inside this register, it will be updated control flow. Let's suppose that the memory overload occurs in the user mode. In this case, the exception is taken to the supervisor mode instead of the machine mode. Because once you update each bit field flag in the machine exception delegation register, exception will be taken to supervisor mode instead of the machine mode. So this is the scenario once we modify the bit flag inside machine exception delegation register.